Let's solve this word problem. You can read the word problem, just simply pause the video. The question simply asks us to find the amount of heat conducted from one end of a poker to the other end in 5 seconds. First thing we'll do, let's draw a picture of a poker. And it would look something like this. You have a handle here, long shank. And if I were to put someone's hand, would be holding the poker here. And at one end of the poker is in a fire, and the temperature is 502 degrees Celsius. In order to show heat, where something is really hot at one end, I like to draw a campfire. This is where the poker is hot, and the temperature at this end is 502 degrees Celsius. And at the other end, where the hand is, it's a cooler temperature at 26 degrees Celsius. And heat always travels through a material in one direction, from a place that's hot to a place that's cold. So eventually the hand here is going to get warmer and warmer and warmer. The equation we're going to use is going to be Q. This is conduction equation, is equal to K A delta T times the time divided by L. This is known as the general equation. What we need is the working equation. In effect, we have to expand delta T. Opening up delta T, the equation will look like this. Q, the heat energy, Q is equal to K. That's the thermal conductivity constant given to us up here. Times A, and delta T, to open that up, it's temperature hot minus temperature cool. Times the time, everything divided by L. Excuse me. Let's make a list of what is given. In terms of the variables. What's given in terms of variables, let's start with temperature hot is 502 degrees Celsius, and temperature cool is 26 degrees Celsius. We're also given the length of this poker. The length will be here to here. And we're given the radius. Radius is equal to 5 times 10 to the minus 3 meters. 5 times 10 to the minus 3 meters. And that simply is equal to 0.005 meters. The equation itself asks us for an area, cross-sectional area. And if I were to open this up or cut through there and look at it that way, I'm going to redraw that here, I would see a circle, and that circle would have that radius, 0.005 meters. That'd be the cross-sectional area. And area has the equation for a circle is pi r squared. So area is equal to pi r squared, and that would simply would become pi times 0.005 squared meter squared. We also need the variable K. K is the thermal conductivity constant given to us here. 79 joules per seconds, meters, and Celsius degree. We also need the time, and time was given to us as 5 seconds. And also in the equation, in our list of givens, we also need to write in what we are looking for. the unknown. And the other unknown for us is Q. Need to find Q. I think we have all that we need. All that's left to do now is take all of these values and place them into the working equation. I'm going to put it way over here. Looks like I'm going to run out of room, so I'm just going to place it here. Q. Q is equal to K, 79 joules per seconds, meters, Celsius degree. And that reminds me that since K, this is the constant, and the constant is given to us in terms of Celsius degree, and it is okay to go ahead and use the two temperatures in Celsius. Were this given to us in Kelvin, then we'd have to change our temperatures to Kelvin, technically. And then we need area. Pi times 0.005 all squared, meter squared. Multiply by that by temperature hot. Temperature hot is 502 degrees Celsius minus temperature cool, 26 degrees Celsius. Within the brackets, I like to put in degrees Celsius, the original temperatures that were given. But actually, when you do the subtraction, the actual unit becomes Celsius degree. And all of this times the time was given us as 5 seconds. Everything divided by the length, or the distance that the heat needs to travel from point A to point B. And that length is 1.2. 1.2 meters. Let's look at the units. I have seconds, and seconds in the denominator cancel out. Celsius degree, ignore the ones that are inside the brackets. It's Celsius degree when the subtraction is made, and Celsius degree. We have 1 meter down here and 2 meters on the top, leaving us 1 meter, and there's 1 meter in the denominator here and 1 meter left over. And all that's left over in the units is the joule. And I've said this before, follow the units. And the unit for heat energy is a joule. So joules on the left-hand side, joules on the right-hand side, everything is ready to go. All that we need to do now is put these numbers into a calculator, and Q in joules is equal to 12.30588 joules. Rounding this to proper significant figures based on the information that's given to us here in the word problem. And I'm only interested in the actual measurements. I've asked that you ignore the temperatures for sig figs. Also ignore any constants for sig figs. So the only measurements left is the length of the poker, 2 sig figs, and the diameter, 2 sig figs. Therefore, we're going to round this to 2 sig figs, and that'd be 12 joules. To round to 2 sig figs, look at that third one. If that third one is less than 5, round down. If it was greater than 5, then I would have rounded up. Therefore, the heat conducted in 5 seconds is 12 joules.